Hello, it's Keith here, and this is lesson 3 of the platform-specific series of my 609 assembly programming tutorials. We're on to the Vectrex today, and we're going to learn how to read in the joystick on the Vectrex. Now, the Vectrex joystick is actually an analog joystick, so we're going to have to read it in an analog format. However, we're going to be using an emulator that uses keys to emulate, so we're going to be getting back some kind of digital values. That's all good for me, though, because in my tutorials I convert everything to a digital value anyway, but we're going to have to look at the Vectrex, and we're going to learn how to actually convert those signals. Now let's go over to the source code and let's see today's example in action, and then we'll discuss how it works. Now in my tutorials I generally try and go direct to the hardware. That's not really the case with the Vectrex. The Vectrex is so complicated, I'm having to do things a bit more crudely, so we're going to be using the operating system to do the work for us. And also, unfortunately, it seems that the emulator massively overclocks my processor and makes my fans loud. Getting louder now. Okay, so this emulator uses the cursor keys up, down, left and right, and then A, S, D and F. Now at the top here you've got the data as it's being directly output by the firmware calls, and the bottom here I've converted it to a sort of bit mask, 1 bit per direction. So if I press up here, you can see we've got a value of 64 here, and if I press down we've got a value of basically minus 64 here. Oh, actually I guess that's minus 65. But anyway, as I say, we're basically going positive, negative, and 0 is the center, which makes a lot of sense. But then I'm converting that to a 0 for up here, 0 for down, and then if we do left and right, you can see we've got the same kind of values here. And then if I press 1, then if I press fire 1 here, you got a 1, 2, 4, 8, and we're just moving those bits into here. So we're reading in from joystick 1 here. Now the Vectrex I believe did support 2 joysticks. I can't get the second one to work. I don't know if the emulator doesn't support it. I guess it doesn't, but even if I try and read it, it's actually locking up the system. So I think the emulator's outputting bad values to the firmware, and the firmware's getting confused. Anyway, that's just a sort of covering note. It's not really a problem. But today we're going to be reading in from the hardware and showing those results to the screen. Now, there are a variety of memory addresses we have to configure to actually set up the joysticks, and then there's a variety of addresses we need to read back from, and some firmware calls we need to call. Now my tutorials are using a header, and they emulate basically a bitmap screen so that my monitor functions work as usual. So we've got some code here to support that. There's the CLS here, and then there's the draw Vectrex screen as part of this loop here. Now another thing we need to discuss is direct pages. Now the direct page for the RAM is at C8 I believe, but the direct page for the hardware is at D0, and a lot of the hardware functions that we can call the operating system require the direct page to be set for them. So we're setting that just here, we're setting the direct page to D0. So that's just something we need to know about. Next, what we need to do is we need to select the directions that we want to read in from. So we basically need to send some kind of fixed codes here to do this. So C8, 1F and 20 need the values 01 and 03 or 00, and 00 would turn off those 2 joystick directions. Now the second joystick has ports 21 and 22, and they need either 05 and 07 or 00. If we turn those on, this example is going to crash. I don't know why, but it will. I'll just try that, 05, 07. And we'll just fire this emulator up here. Well, that's it. That's all we're getting. It seems to just get stuck forever. So as I say, I kind of wonder if the emulator is not outputting anything, and the reading those joystick ports just crashes it. Anyway, so that doesn't work so well. So we were not going to use that. So once we've selected the directions we want to read in using these hardware values here, we then use the function F1, F8, and that will read in up, down, left and right, and it will restore the results to these memory addresses here, and we'll be reading those in just a moment. We can then also use function F1B4, and that will read the fire buttons 1, 2 and 3 and 4. Now the accumulator is used as a response mask. If I just fire this up here, if you watch the accumulator, you'll see that it kind of blips when I press one of these keys here. But if I change that to a 0, and then I press again, well, now the value is sticking around much longer. Now if I'm holding down, it's showing a 1 or a 2, whereas before it's only when I initially press the key it shows as a value there. So that might be useful in some cases, but anyway, these will feed in the values into some fixed memory addresses that we can then read back later on. So here we're loading in C81B for up, down, left and right, and here we're loading C80F for buttons 1, 2, 3 and 4. Now once we've read those in, we're actually having to convert the analog values into digital. So I've got this function test1 axis here, and we're using the test values hexadecimal 40 for the positive 64 and hexadecimal C0 for the minus 64, and we're just testing to see if we've got a value outside of those ranges. If we have, we're considering that direction to be pressed. If we haven't, that's the dead zone, and we're considering the joystick to be centralized. As I say, we're converting to digital here. So we're using these here. Now actually the y-axis is flipped, so we're just flipping the value before we use that function to convert the y-axis so that it's the other way around. But what we're doing here is we're basically shifting bits from each of these functions and the joystick into the B register, and so when we actually get to the end here, we're showing the final result in the B register just here. So that's, we've got a nice simple function that we can use. As in my multi-platform code, I always try and convert to this common format. So if you wanted to read in analog values, you would be wanting to read in here, and you'd also want to get a better emulator because this one's using cursor keys, so not very analog at all. But if you just want digital values, then really you want to convert the values you read in here in some way and convert them into a fixed 1 bit per direction, which is what I've done here. So because we're using the firmware, it's relatively straightforward. We just need to select the directions we want to read in with these. We want to then run these two calls, F1, F8 to get the directions and F1, B4 to get the fire buttons, and then we can just read in from these memory addresses to get the results. Pretty straightforward. And that's all we're going to be covering for today. So being as a game system, the Vectrex has a good joystick, and it doesn't really have a keyboard. I know there's some weird device you can add that gave it a keyboard much later, but we're not going to count that. So that's all we'll be covering today. We'll be coming back to the Vectrex later on with a monstrous graphics tutorial which I've written, and also some sound. So if you like seeing some Vectrex, please like and subscribe and stick around. You know, hopefully I'll have some stuff to entertain and amuse you. You can of course get the source code for today's example. That's the point of all of this. So please go to my website if you want that source code and have a go with it yourself. If you've liked what you've seen, please like the video. Liking the videos makes YouTube recommend them to other people who might also like the video. And if you're not subscribed, please subscribe, because I have to spend hours and hours reading up the documentation to keep writing these tutorials, and it's a lot of work, so I need to know people are actually enjoying them. Anyway, whatever you do, I hope you have a lot of fun with your programming on the Vectrex. Thanks for watching today, and goodbye.